This is for Year 12 Specialists. Question number 3 looks at 3 methods that comes up with the value of y without actually solving the differential equation, coming up with the expression for y. The first one is using Euler's approximation, and I'm going to use the calculator to go from x equals 2, y equals 5 to estimate y when x equals 3 using steps of 0.1. So I come to menu, I come to e-activities, I'm going to use Euler's activity, and looking here I've got my expression for the derivative, which is going to be, I leave the equal sign, and I've got 4x plus 4 divided by x squared. And xc. My starting x is 2, my increase is 0.1, my starting y is 5. And then I come down and I find out when x equals 3 that y equals 7.3507, and to 2 decimal places 7.35 is the estimate using Euler's approximation. The second method asks you to consider slope fields and to use the calculator. Okay, so if I use slope fields, I come back to menu, I come into difference equations, I come to y dash, and y dash in this case is bracket 4x plus 4 divided by x squared. And that gives me that. And since I'm looking from in the first quadrant, I'm going to change my window to negative 0.1. I don't want to lose the axis. But I'm going to go across to 3, and I'm going to go up to 10. And my initial condition is x equals 2 and y equals 5. Okay, so it's redrawing it for me. The reason that I wanted to use negative 0.1, now I can see x equals 1, 2, 3, so 1. So these must be halves because this is 2, 5, so that's 2. So that's 1. Okay. So I know that it goes through 2 and 5, so that's a point. I know that's a little bit left of 1. And if I use analysis trace, I'll try and find my prediction for x equals 3. Now I'm thinking I'd like to go to 4 on my x because it's going off the screen, and analysis trace. .9 is 2.998 is 7.28. I'm going to use 7.28 as my estimate. And at 3 I need to be at 7.28. So I'm comfortable that this is going to be my curve. And I'm going to label 2 and 5, and I'm going to label 3 and 7.28, and I need to do appropriate about 10. So I'm just going to put them close to the curve that matches the gradient of the curve, and I can see that some there might go in that direction, some there will go over in that direction, and that's close enough to 10. Okay, so 10 arrows, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The point correct, 2, 5. The curve is correct, and the estimate at 3, 7.28. Beautiful. And the third method uses the definite integral. So I know that at 2, it's going to be 5, so plus 5. If I go from 2 to 3, from 2 to 3 of 4x plus 4 on x squared dx, that's going to give me my new estimate for y, because I'm using the integral from 2 to 3 to find out that change in y, and then I add it to the original value of y. So if I jump back into main and I bring up the keyboard, math to integral from 2 to 3, because I know that at 2 is equal to 5, and this is going to be 4x plus 4 over x squared with respect to x. And that gives me an answer, but I'm asked to do to 2 decimal places. So 7.2885, 7.29 is the most accurate answer. So 7.35 using Euler's approximation, 7.28 using slope fields, and 7.29 rounded to 2 decimal places are the three values for y in question number 3.